Let's look at question 33. Search in rotate sort array. The input is a two parameter. First one is an int array and the second one is target value. The input in array is sorted but rotated too. What it means for rotate? So rotate means in some location they start to rotate. So the first element in this array is not the smallest. Some point we see this is the key point. That one is the smallest. And then go to the end and rotate from the left. So actually this array still is sorted, right? The question also asks to finish it for the time complexity is big O log n. So big O log n is binary search. So you cannot compare each element in the array to find the target. Okay, let us to implement. Actually, to solve this question is very go straight. First, we find the key position in where they start to rotate. Help function find the key. In this one, we write recursive function. In this one, we find the key value from which point they start to rotate. So if numbers left less than the numbers right, so the left point is rotate start point. If left equal right minus 1, this means left right is the neighbor and the left is bigger than the right value. This one we return right because the number of the right is smaller than the number of left and they are neighbor, so the right is the number. And then right, okay, and if we have so other case is we find the middle of the right and left. So if middle value is bigger than numbers left, in that one we call the recursive. So recursive is not happen from the left to median, so they happen from the median to right. And else will return recursive it from the left to median. So we are done for the find key. Now we have the key value. Minus 1. Okay. We have key, after we have the key value. So by the key value, we split the whole array from 0 to k minus 1. And then from k to numbers lines minus 1. Both is included. So we have a 2 array. And first we decide is the target in this 2 array and in which one. And then we use the binary search to find exactly index or return -1 if the target is not hit this array. Okay. However, when we check this one, so we find if k is 0, it means they give us the rotate start point is 0 index. In that one, k -1 will be out of boundary. So we need to do is if k equals 0, what happen? So after decision, we will know the left and the right to search the target. So in the beginning, we set up the left is -1. In that case, left will be the 0. We will search whole array to find the target, right? And then we will do the else. If numbers 0 is bigger than the target, no, if number 0 is small and equal to the target, and numbers k -1 is bigger and equal to target, in that case, the left will be the 0 and the right will be the k -1. Else, if numbers k is small and equal to the target, and numbers right now the right is the numbers lines -1 is bigger equal target. In that case, the left will become the k. Right is not changed because the right value we already have the initialized value for the numbers lines -1. Okay, after this one, if left is -1, it means this target value is not inside left, is not inside this array. So we return -1. Actually, in that one, we also can do the check. If target is less than numbers 0 or target is bigger than numbers right, we return -1. It's not in this whole range. Okay, after do this one, we need to use the binary search to find which index is equal to the target, right? So if we will do the while loop, the left less than the right. Okay. Before do that one, we also need to do one more thing. If left equal right, in that case, if numbers left equal to target, return left, else return -1. Okay, left less than the right. In that one, if numbers left equal to the target, return left. If numbers right equal the target, return right. If left equal right minus 1, return minus 1. The reason is there's a neighbor and they are not equal to the target. We already do the research, binary research to end off this whole search. So in that case, we return the minus 1. Then we have same thing. Middle index is left plus right divided by 2. So his value is numbers middle index. So if m value is target, we return m index. Then if minus value is bigger than target, right? In that one, right will be set to m value, else left will be set to the m value. So then we go through this loop. If not match, we return minus 1, because they will return from either way, from either of the 3 way. So if finish left is bigger or equal to right, they will directly return minus 1. Okay, let us try it. Okay, for test case is passed. Let us submit it. Is something wrong here? Okay, so what is the error? So if okay, out of 4. Okay, so if they give the one element here, 0 and 0, left and right both is 0. So return left, left and equal to return. Okay, so for that one, we need add less. So for that one, we need to add this one. So test data, no here. Return right. Oh, okay. The always will be the okay. Equal this one, or left equal right. Okay, and submit it. Still is something wrong. The error is out boundary, so this line will out of boundary. So why the value is out of boundary? We check here. So 1, 3, 5, when they come in, let me see here. Oh, here we have a typo. This will be the m index, not the m value. Okay. Yeah, so we are done. Performance is okay because sometimes the 1 second and 0 second same thing. This depend in current LeetCode server speed. For that one, we have two log_n algorithm. Find key is a log_n. The search is a log_n2. So finally, the time complexity is still a big O of log_n. Space use for that one is log_n because we have recursive. For that one, we do not use extra space. So finally, space complexity is big O log_n. Thank you for watching the video.